Hi everyone, welcome to another Data Analytica video. So in this video, we will explore how Polars lets you write SQL-like analytics directly in Python with expressions like pl.col, pl.when, and groupby.aggregate that look clean, and it can scale to millions of rows and run faster than Pandas or Spark in many cases. So I'm here on Databricks Free Edition, and let's create a new notebook. And let me name it Polars Analytics. So the goal for this session is going to be introduce Polars expressions, how to write SQL-like queries, and to cover advanced topics like window functions, join, pivot, exploding list, conditional logic, and custom UDF. So like other videos, in this video also we'll focus on the practical examples and exercises that can actually be adapted to real data sets. So let's start. And let's start with installation. So let's install Polars. Okay, it's getting installed. Okay, so it has been installed, and now let's start with importing. So let's import Polars as PL, and then we will be using NumPy as NP, and we will be using datetime, so we'll import that as DT. Okay, so let's run this, and it ran successfully. So the next thing that we're going to do is we need to create a data set. So create a sample data set. So of course we're going to use a small data set to use. Okay, the data set will be using np.random seed, and this 42 is actually to create the same data set every time you run this. And let's say the size is going to be 20, and we'll have 3 categories: A, B, and C. And the data frame, let's create it, pl.data frame. Okay, and the first column is going to be ID. ID is going to get created using np.arrange, 1 n+1. And the next column is going to be category, np.random.choice. So we'll be using category cats, a list that we already created, and size is going to be n. And the next column, value, np.random.normal. and size is going to be n, and we'll round it with 2 decimals and then timestamp. Date time for this year plus dt dot date time delta time delta days equal to end of x equal to n. Okay. Sorry, it's not df dot, it's actually dt dot datetime. Okay, and we'll also be adding one list column for explore demo. So df dot with columns a list with pl.int ranges 1, small list. Okay, so let's run this. Okay, so it ran without any error and we have now a data frame created. And let's print it to see how the data looks in that data frame. Okay, so here we have 5 columns: ID, category, value, timestamp, small list, and its type. Here you can see it's ID with integer, and then category, string, value, float, timestamp, date time, small list. Okay, and we have size of 20, and then we have date timestamp, and then we have a list under this column and with 2 decimals here. Okay, so let's move on. So the first thing that we're going to cover is actually, let's say, expression. Okay, basic expressions. Let me keep it as a markdown. Okay, basic expressions. So we know that there is this pl.col, which actually can be used to reference a column and column name, and it actually, what it does is it references a column. And then there is pl.lit of value, which actually gives you the literal value. And then there is alias. Which will rename that expression. And for any arithmetic, it's actually done how expression 1 plus expression 2 or expression into 2. So these are all arithmetic expressions. Okay, so let's have a small expression created to see these basic expressions. Okay, so how to do that? Inside this parenthesis, df.select pl.col of id, pl.col of value. So here pl.col of value multiplied by 1.1, and let's call this new row, sorry, column pl.percent. So it's value plus its 10%, and then we can have pl.col of category, and let's call it as cat. Okay, so let's run this, and here you will be able to see it's a shape with 20 rows and 4 columns, and here you have id, value plus 10%, and its category. Okay, then we can have another code to see that we can have to show like actually like how to use using dot round off and dot floor, etc. Okay, so how to do that? We can let's df.select pl.col value dot mean dot alias. So let's call it mean value, and let's have pl.col value dot median alias median value standard deviation, and let's call it as standard deviation value. Okay, so let's run this and see what all columns we get. Okay, so we have, as you can see, we have here one row with 3 columns with mean value, median, and standard value, standard deviation of the value column. So using this different mean, median, standard deviation, etc., this can be composed in with column like here. So this looks very similar to Pandas or Spark, and now the next thing that we're going to see is select with columns and with column. Okay, so the select actually creates a new data frame, as you can see in the above expression, with only the provided expressions. Okay, and then we have with columns. So here what it does is it adds or replaces multiple columns. And then we have with column. So this is actually applied when we add a single column. Okay, so the next thing that we are going to see is add computed columns using expressions. How we're going to do is, let's say we have pl.df with columns. Say pl.col of value So let's say we need to find out a share of each value on total. So how we're going to do it? We'll actually pl.col of value divided by pl.col of value dot total, sum total. And this expression can be actually called value share. Okay, and next thing that we're going to do is let's rank this session. So let's rank this value. So how we can do it? pl.col value dot rank of, we'll use dense method, and we'll call it as value rank or dense rank. Okay, now it's actually a chained expression where we can see with this I will select all the different columns that I'm required to see in the data frame. So here we have ID, category, value, value share, dense rank. Okay, now let's run this. Okay, here you can see that there is this ID, category, value, and then the new two columns which are created, value share and dense rank. And value share is going to be the value divided by total value, total sum of that column. So it's going to give you the share. And then there is this dense rank, which will actually rank it based on the value. And here you can see that the smallest value, the 21.3, is ranked with highest rank, and then it actually gives for this whole 20 rows. Okay, so yeah, that's it about calculating a new column. So here we used with columns, and here we created two new columns. So, and we did the computation. So yeah. Okay, now let's move on. So the next thing that we're going to see is filter. So filter, like for other libraries, we know that it's actually important when you need to filter some rows or some kind of like expressions from that, using expressions from the whole data set, whole data frame. So how are you going to do it? Filtering or filter. So filter is actually the expression, and Boolean logic expressions can be used inside filter. Okay, so let's see an example. Let's filter all the rows where value is greater than mean value. Okay, so how we are going to do it? Let's find out what is actually the mean value. df.select pl.col value dot mean and let's get this item. Okay, and let's have a high, which is actually like the filtering that we're going to do it. pl.col value is greater than mean val. Main value is going to be mean val. And we're going to print all the values greater than that mean value. So let's run this. Okay, so the mean value that we calculated is actually 42.406, and all the values greater than this 42 or the mean value 42.4 are actually going to be filtered for this data frame, the high data frame, and we are actually printing that here. So here you can see that all the values that are actually in this value column are actually greater than this mean value. So using this df.select and then filter, and in this itself we have actually specified the Boolean logic expression. So with this we are actually filtering the rows. Okay. And I would like to show maybe another example for this one. So let's say df.filter, and I'm going to filter all the column where the category value is actually A, and pl.col value is greater than, let's say, 60. Okay, now let's see. Okay, so we can see that there is actually one value greater than 60, that is 71, but for 71 the category is C. So if we had put C here, then we would have got, okay, this one. Okay, so this is how you can actually combine different logic expressions, and like we do it in Pandas when it comes to the conceptually they actually very similar. We can use the Boolean mask like ampersand or equal to, greater than, all these things. Only the difference is actually the referencing part, because polars actually uses lazy expressions. Like instead of directly indexing the data frame, here we use a column, pl.col. So, but because these expressions are actually compiled and optimized, they actually more faster. They are faster. Okay. So let's move on and let's go to the next part, which is group by and aggregation, which is also very important. Okay, here group by accepts columns, and then use aggregate with expressions. Okay, so let's see how it's done. Let's do an example. So what we are going to do here is actually we will be actually calculating the average value, its length, median value, standard deviation value, and the max ID for each of category. So we are going to group by category and df.group by category, and then we'll aggregate on value column. So how we will do it? Show you. So using a list of expressions, let's say we will actually calculate length first, or number of rows for each category in each category. So using pl.length, and let's call this as n, or the number. And the next thing that we're going to do is we'll calculate average value. Okay, so how we're going to do it? We will pl.col of value and we will rename that to average value. And pl.col value median. Let's calculate median areas value pl.col value dot standard deviation. Let's calculate standard deviation value and then the max ID. So for this we will use the max ID column, and then dot max dot alias of max ID. Okay, so here we are, and now let's run this and see if we get the group by. If we get these all different values, average value, median value, standard deviation value, max ID, and an n on each category. Okay, so here we are, and if you see here we get like average value for median, standard deviation, max ID for each category, and the total number. So yeah, so the thing is that like group by and aggregation. So here we can group by on columns or column, and then use the aggregate with the kind of expressions that we would like to aggregate those groups on. Okay, so here we have seen, let's say like one group by category, one column group by, and like I mentioned before, it accepts columns. So let's say another case with multiple columns or more than one columns. Okay, so let's add more than one column in group by. Okay, so let's have, so what we're going to do is we'll actually have a weekday. So you will use the timestamp column, and then we will actually convert that to weekday, and then we will see how each category's value or average value on each weekday. Okay, maybe I can actually write it here, what we're going to do. Average value and number of rows on each weekday for each category. Okay, so here we are, and we df dot. So first thing that we're going to do is we will actually convert timestamp column, pl.col timestamp dot dt dot weekday, and we will call it as weekday. Okay, and the next thing that we are going to do is dot group by, and then we will use category, and then the new column that we created, weekday, and then we will have aggregate, we'll using the length function, we'll call it as n, and then we will have average value. So for that we will use value function, value column, and then we will rename it as average value. Okay, and then we will sort it by category and weekday. Okay, so that's it, and then let's run it. Okay, so data frame has with columns. Okay, yeah. Okay, so here we are, and here you can see that we have actually category and then weekday in integer form, and then we have how many rows or how many entries for each weekday for each category, and then we will calculate, we have calculated average value. Okay, so I think we have actually covered till group by for this part of this video, and then in the next part we will actually cover the window functions, rolling aggregations, and then we'll also see joins, and then pivot, and okay, maybe I can write here for next part, window functions, joins, pivot, and then list and explode, and then conditional logic, that is when or otherwise, and then we will also see, we have already covered this in eager versus lazy computational format like video that we already uploaded, but we'll also cover it here to be, to show you the lazy data frame best practices. Okay, so then see you in the next part, and I hope you enjoyed this part, and please let me know your comments. Thanks for watching.